Welcome to Collapsed Latents, this week in AI, where we cut through the noise and bring you the most groundbreaking research shaping the future of artificial intelligence. I'm your host, and this week, we're diving into 5 revolutionary papers that are redefining how AI sees, thinks, reasons, and acts in the real world. From teaching AI to research like a human, not just answer questions, but investigate them, to building agents that can cancel an order in a live e-commerce system, to models that think with maps, see like babies, and even distill intelligence in ways we never thought possible. This is AI evolving beyond language, beyond imitation, into true perception, purpose, and agency. Let's jump in. #1. VideoDR, the first benchmark for video deep research. Imagine you're watching a museum tour video. A statue glints in the corner. A map flashes on screen. The question, what's the registration number of the artifact closest to the main entrance? You don't just scan one frame. You track visual cues across time, cross-reference with the museum's website, verify the answer, using the video as a starting point, not the endpoint. Until now, no benchmark tested this. Existing video QA datasets assume all answers are in the frame. But real-world knowledge, it's scattered across the web. Enter VideoDR, the first open-domain video deep research benchmark. It forces models to search, reason, and verify, using video as the anchor, not the finish line. Researchers built 100 high-quality samples from travel vlogs, documentaries, and tech demos, each requiring multi-frame visual anchoring and multi-hop web search. But here's the key. Only questions that fail both a video-only and web-only test make the cut. That means the answer only exists when you combine vision and search. They tested 6 top multimodal models under 2 paradigms: workflow, extract vision first, then search, and agentic end-to-end autonomous search. And the result? Agentic isn't always better. Models like GPT-5.2 and Gemini 3 Pro Preview do better on hard tasks, because they remember visual details across long chains. But others, like GPT-4o, plunge on high-difficulty questions, because a single early misperception causes goal drift. Once the anchor is lost, the model spirals into hallucinated web noise. The real bottleneck: long horizon consistency. Not tool use. Not data. Staying on track when searching across hundreds of pages, guided only by a fleeting visual memory. VideoDR isn't just a benchmark. It's a wake-up call. AI doesn't just need to watch videos, it needs to research them. #2. EnvScaler, teaching AI to act in real systems. Ever asked a chatbot to cancel an order and gotten silence, confusion, or wrong steps? That's because most AI assistants aren't agents. They're just smart guessers. They can talk, but they can't do. Enter EnvScaler, a breakthrough framework from Renmin University that builds realistic, executable environments for training AI agents to interact with real-world systems, like e-commerce platforms, messaging apps, or banking tools. The problem? Real systems are locked down. Simulators are full of hallucinations. Manually building them, like drawing 1,000 Lego models by hand. EnvScaler solves this with 2 smart engines. ScaleBuilder mines real-world tasks from open datasets and reverse engineers the full environment, including state, tools, and rules, in Python. SenGenerator acts as an AI storyteller, creating 7,000+ complex realistic scenarios, complete with initial states, challenging goals, and rule-based validation. But here's the genius: it tests the environment itself. 2 AI agents run in a loop, one tests, one verifies. If the environment breaks too often, it's discarded. Only high-quality, real-code environments survive. Then researchers trained QN3 models using EnvScaler, and the results: 20–30% better performance on major benchmarks like BFCL, TauBench, and ACE Bench. More importantly, the models took longer, more thoughtful action chains, showing deeper reasoning, and generalized even to unseen environments. This isn't just about better accuracy. It's about true task completion, not just calling the right tools, but achieving the right outcome. EnvScaler proves, to build agents that act, you need real environments. And now we can scale them, without real-world access, without hallucinations. The future of AI isn't just talking. It's doing in real systems with real rules. #3. Thinking with map, AI that uses maps like humans do. You're looking at a photo of a street in Xiamen. You don't just guess. You open Google Maps. You search for red awnings, check POIs, zoom in, verify the layout. That's thinking with maps, a process so natural we don't even notice it. But AI, it's been missing the map. Enter Thinking with Map, the first framework to equip large vision language models with real map tools and train them to use them like humans. The model doesn't guess. It hypothesizes, queries the map, cross-validates, and refines, just like a person. In one example, a photo of twin towers in Xiamen. The model searches for nearby POIs, a bar, a convenience store, a bakery. Then it checks the map. Are they spatially consistent? Is the road layout correct? Only after multiple parallel reasoning paths, each exploring different hypotheses, does it converge on the answer. Latitude: 118.08756, longitude: 24.44007. And here's the technical brilliance: parallel test time scaling. Instead of one path, it runs 4 in parallel. A verifier model picks the best, most causally grounded trajectory. Trained with Group Relative Policy Optimization, GRPO, the model learns to explore efficiently, rewarded for accuracy, penalized for hallucinations. The result? On the hard split of MAP bench, a new benchmark with up-to-date real-world street views, accuracy at 500 meters jumped from 4.02% to 14.86%, over 3 times better than the best closed-source model. And when you scale up parallel sampling, you get near-oracle performance. This isn't just about geolocation. It's about grounding AI in reality. No more hallucinated POIs. No more bias toward well-documented regions. Just real, verifiable, map-based reasoning. The message is clear. The most powerful tool for understanding the world isn't just a model. It's a map and the ability to use it. #4. Baby vision, when AI can't see like a child. In January 2026, a new benchmark revealed a shocking truth. Even the best AI models can't see like a 3-year-old. Meet baby vision, a scientifically grounded evaluation of prelinguistic visual reasoning. Tasks that children master before they learn to speak. Tracking a winding path, understanding occlusion, mentally rotating 3D shapes, spotting subtle pattern differences. But the models, the best Gemini 3 Pro preview, scored just 49.7%. Worse than 6-year-olds. Some models even underperformed 3-year-olds. Why? Because today's multimodal models don't see, they describe. They compress vision into language, then reason over that proxy. But many visual abilities, like tracking a line through intersections, are undescribable. They're perceptual, not semantic. To fix this, researchers created Baby Vision Gen, a generative extension. Instead of answering with words, models must draw, circle, or annotate directly on images. And the results? Promising. Models like Sora 2 and Veo 3 began to think visually, drawing correct paths, highlighting patterns, completing transformations. But even then, no model hit more than 18.3% on the full benchmark. Why? Because they still lack a persistent, coherent visual memory, the ability to maintain a mental model of the world across time. The takeaway: high-level reasoning without foundational perception is not intelligence. It's hallucination. The future isn't more data or bigger models. It's architectural innovation, models that reason in visual space, not language space. We need systems that see, not just talk about seeing. #5. DASD-4B thinking, the smartest small model you've never heard of. Finally, we come to DASD-4B thinking, a 4 billion parameter model that smashes expectations. How? By rethinking knowledge distillation, not as data curation, but as a principled interactive learning process. The old way: just copy the teacher's answers. But that creates 3 problems: poor distribution coverage, misaligned learning, and exposure bias. DASD fixes all 3. 1. Temperature-scheduled learning. Start with low-temp, stable data to build a foundation, then switch to high-temp, diverse, to expose the student to rare, valuable reasoning paths. 2. Divergence-aware sampling, DAS. Prioritize teacher-originated sentences, where the teacher is confident but the student isn't, so the model learns where it's wrong. 3. Mixed policy distillation. Train on student-generated responses, then let the teacher correct them. This teaches the model how to recover from mistakes. The result? A 4B model that beats 32B models, 253B models, and even NVIDIA Nematron Ultra 253B on math, code, and science benchmarks. And it did it with only 448,000 samples, an order of magnitude less than most open-source efforts. Even more impressive, the same pipeline boosted a 30B mixture of experts model, without reinforcement learning, without proprietary data. This isn't just a model. It's a paradigm shift. Efficiency, transparency, and performance can coexist. And the best part? It's open-sourced on Hugging Face and Model Scope. The dream of compact, high-performance, fully open reasoning models. It's here. So what's the big picture? This week, we've seen AI evolve from watching to researching, from talking to acting, from guessing to thinking with maps, from describing to seeing, and from scaling up to scaling smart. The future isn't about bigger models. It's about better architecture, deeper grounding, and true agency. AI isn't just getting smarter. It's becoming more human, not in language, but in perception, purpose, and action. And the most powerful insight: the real bottleneck isn't data or compute. It's consistency. The ability to stay on track across long chains of reasoning, to remember, correct, and adapt. So if you're building, researching, or just curious, go try DASD-4B thinking. Explore EnvScaler. Play with VideoDR. Test thinking with map. And ask yourself, can my AI really see? Or is it just describing? Because the next frontier isn't just intelligence. It's understanding. Hit like, subscribe, and let me know in the comments, what kind of AI agent do you want to see next? Until next time, keep exploring. The future is interactive.